course to steer, practice problem 3. We're going to write down everything in the problem first, right? Course to steer, practice problem 3. And it says, while on a course of 214 degrees, a light bears 9 degrees on your port bow at a distance of 7.4 miles. Gives us our course. Our course is equal to 214 degrees true. It gives us a bearing of a light. The light bears, the bearing is equal to 9 degrees at a distance of 7.4 miles. The distance to that bearing is 7.4 nautical miles. And it continues on to say, what course should you steer to pass 2 miles abeam of the light, leaving it to port? So the question is, what course to steer, right? What is that course to steer? And it gives us another distance, 2 miles. So distance abeam equals 2 nautical miles of the light, leaving it to port. So 2 nautical miles to port, leaving it to port. Now we have our information. We can make a triangle, find our angle, and then correct our course. So where are we? 214. We're somewhere, 270 is here. We're going to be pointed below 270. So something like that. This light is over here and it's 7.4 miles away. And we want to leave this where? 2 nautical miles to our port. So if we want to leave this light to our port, we're going to be somewhere in here, right? That makes sense. And now it's to port, abeam into port, which means this is 90 degrees. And it gave us 2 sides, right? It gave us opposite and hypotenuse. So we'll put those 2 sides in there. We want to leave it 2 nautical miles to port. Boom, double check, that's good. 2 nautical miles. And it said this distance from where we are to where we sight that light, 7.4 nautical miles. Good. And now, to find the course to steer, we need to find this angle. This angle we call theta. Don't worry about its name. We have to give it a name, so we're going to call it theta and use that little weird globe symbol. And to find that angle, we use the formula. Theta equals sine -1 opposite over hypotenuse. What is the opposite and what is the hypotenuse? Let's check that out. The opposite, it's all relative to this angle. So opposite that angle is 2. And the hypotenuse is the longest side, which is always going to be across from this angle here. So this one equals the hypotenuse. So now we have our numbers. So opposite is 2. 2 divided by hypotenuse, 7.4. All right, let's see what that equals. Our calculator is going to give us this answer. So we'll just punch it in. Okay, on, clear, and we say the second button, second, sine inverse, or sine -1. There it is. And now we put in our division problem. 2 divided by 7.4. Okay. 2 divided by 7.4 equals 15.68. We're going to round to the nearest degree. So that 15.6 will turn to 16 degrees. 16 degrees. Now we need to correct our course to find our course to steer. So we write down our course. 214 degrees. Okay? And it said that this light bears 9 degrees. Oh, look at that. 9 degrees on the port. That's important. Important. So 9 degrees on port. So if we're at 214, like this, and that thing bears 9 degrees on our port, what are we doing? We're turning towards it. If we're turning this way, what do we do with our degrees? We are going to subtract. So minus 9 degrees. 214 minus 9 equals, let's just do it on our calculator. 214 minus 9 equals 205. 205 degrees now. And so from that 205, that's going to be, this line is represented now. That's 205 in the problem. And so we need to find this one, right? So 205, and we need to leave this thing 2 miles to port. So if we're here and we correct this way, what are we doing with those 16 degrees, right? We calculated this to be 16 degrees. What are we doing with those? Woo! Correcting this way to leave it to port. So we're going to add, right? As you go around the compass this way, we're adding. So we're going from here to here. We're adding that 16 degrees. Plus 16 degrees. 5 and 6 is 11. 1, 2, 221 degrees true equals our course to steer. Let's double check that. This is problem 3, C, 221. And let's make sure we didn't get tricked. 3 is C. That's course to steer, practice problem 3. We're on to 4.